All right, today is December 14th, 2011. We're on lesson 7.2. Yesterday, we were calculating the amount of a regular annuity. Today, we're calculating the present value of an annuity, okay? So how much an annuity would be worth in today's value? This is the formula we're going to be working with today. Make sure you have it down. So, very first example in your textbook is on page 420. Okay, so Victor wants to withdraw $700 at the end of each month, okay, for 8 months, starting 1 month from now. His bank account earns 5.4% per year compounded monthly. How much must Victor deposit in his bank account today to pay for the withdrawals? Okay, that was a lot of information in 3 sentences. We need to try to organize it. So we have here many different variables that we need to plug numbers in for. Okay? In each of the formulas, so today we're using present value, we have one. Oh, you know what? That's not the right formula. So, our formula we have here. The present value is equal to your regular payments. So there's already 2 variables. We have an I and we have an N. What's important about it is our I has a formula to calculate it, and so does our N. So we end up with 1, 2, 3, 4, 5, 6, 7 different variables in these equations. We have to make sense of what they've given us. So we're going to reread the question again. Victor wants to withdraw $700. So that $700 are the regular payments. So our R value is going to be $700. So we've got that part of the formula. You know what we'll do? We'll bring the formula in here. Okay? Let's move that up. So our R is $700. All right, so our regular payments were $700. He says he wants to withdraw this at the end of every month for 8 months. So what we need to figure out is the compound periods. It says that his bank account earns 5.4% interest each year. So the overall interest rate they're giving us, which is our R, okay, that's the interest rate, is 5.4%, and in decimal form is 0.054. So we've dealt with, so far, uppercase R and lowercase r, regular payments, and our interest rate. The compound period is monthly, okay? So in other words, our C, which stands for compound periods, our C is going to be 12, because our compound period is monthly. There are 12 months in a year, so our compound period is 12. We're going to figure out what other variables we need to deal with also. So far we've taken care of lowercase r, uppercase R, C. I need to figure out how many years this is going to be. So, since this is actually measured in compound periods of per month, okay, that's going to change our numbers a little. Because it's compounded monthly and we're actually not being measured in years, it says that this guy is only dealing with 8 months. What that means is our compound, our N, we actually don't have to calculate because our YR, which is normally years, we're not putting this money in for a year. So that's going to fall off, okay? And we're only dealing with 8 months. So what ends up happening here is our C doesn't become very important. We have to make sense of what the question's asking. So the question asked us for 8 months if he compounds it. So our N is going to be 8 times, okay? Because he's putting the money in for 8 months, and it's compounded per month. One way you could look at it is if you wanted to put your years as 8 and your compound periods as 1, because he's doing it monthly, okay? N is a tough one to calculate. You have to make sense of our question. So our C isn't that important in this question. We can go straight into our N because we know he's compounding it 8 times over the course of this annuity. So we've now dealt with, in terms of our formula, we have an R, we have an N, we have a lowercase r, okay? So we still have to figure out our interest rate. Since our interest rate was per year, we're still going to have to calculate our I. This is per year. So our I, which we'll use a different... Okay, so our I is actually going to be our interest rate divided by our compound period. So like we said before, there we go. Our compound period, our I was going to be equal to the 12 months in our compound period, because this is yearly, divided by our interest rate, which is 0.054. Okay? So we need to calculate our I in this question. So when we go to calculate that, our I is going to be equal to 0.054 divided by 12. 0.0045? I think that's what it says. Okay, so we get 0.0045. So we've now figured out all the variables in our present value formula. We have our R, which is 700. We've calculated our I. Our interest rate was per year, and we know it was compounded monthly. So we had to divide the interest rate by our compound period. Our N, which was covered in months, he's only keeping in there for 8 months. Okay? So our N only needed to be the number 8. Okay, another way we could describe N, instead of just trying to do it in our head, is we can actually find out the amount of years and the compound period. So our C we had figured out, which was equal to 12. We can figure out our YR, okay, our years. Now he said it's 8 months, so what that's saying is it's actually not a full year in this case. Okay, so our years in this case are going to be 8 out of 12, okay, because it's only sitting there 8 months out of the 12, so it's not actually a full year. So in order to figure out our N, we can plug that value in with our compound period, and we're going to end up with the same number you'll see. So N will equal our years, which are 8 over 12, multiplied by our compound period, which was 12. Does anyone know the shortcut to multiply these right here? What's it going to equal? Okay. If you take a look at these two numbers here, these 12s will cancel each other out, and our N will end up being 8, which is another way we could have calculated, okay? So I wanted you guys to do it in your head. If you have trouble with that, you can put in years, and in this case, it wasn't a full year. It was 8 months out of 12. So our years is actually a decimal. If you prefer to work with it like a decimal, you could have put 8 divided by 12, not 0.8, which we got 0.6 repeated, and you could have multiplied that by 12, and you would have got 8, okay? If you want to work with it like a decimal, that's fine. The key to these questions is finding all of the variables in the question, okay? So we're actually going to put everything in now. We have a lot of our variables. We're going to plug everything into our equation. So our present value is equal to our regular payments, which were $700. Okay, we're using this formula. 1 subtract, bracket 1 plus our I, which was 0.0045, to the power of negative n. So our 8 here is actually negative. And all of this is going to be divided by 0.0045. This is the next part of it. We need to actually equate all of this properly according to BEDMAS. So according to BEDMAS, we deal with our brackets first. 700, 1 subtract. 1 plus that is 1.0045. to the power of negative 8, because our n is negative, divided by 0.0045. Okay. Next step is we've dealt with our one bracket. We have an exponent. So we need to put 1.0045 to the power of negative 8. That's why we went over exponents last chapter. We knew how to put these in. So when we go to calculate this, 1.0045 to the power of negative. Oh, that's not a negative one. So when we put 1.0045 to the power of negative 8, we have it down here in the calculator, and we're going to write it into our question. That's 700 times 1, subtract our number, which is 0.9647, okay? I'm going to round it a little. So I've now calculated with our exponent, divided by 0.0045. 9647. We're going to subtract the brackets. When we subtract them, we get 0.03528 multiplied by our 700. Divided by 0.0045. We're going to multiply the top of this. Okay, so we're going to put that number into our calculator here. 0.03528 multiplied by 700. 24.696. Thank you, Matthew. So we get 24.696, still divided by our other number here, which is 0. And when we divide the two numbers, we're going to divide this by 0.0045. What is it? Did I not put enough zeros? Oh, I think it did. 5,488, right? 5,488.28, I guess, is our amount. So this is the present value of what this is worth here. So we need to try to make sense of what we've just calculated. So it said Victor needed $5,488.28 in the bank in order for him to withdraw. Is it AL? I think that's withdrawal. Withdraw $700 per month for 8 months. Okay? So let's think about this if he wasn't getting any interest in the money in the bank. If we were to actually multiply 700 times 8 months, $5,600. So according to this, if he wasn't getting any interest at all, he would actually need $5,600 in the bank in order to withdraw $700 8 times. But because he is getting interest in the amount he has in the bank, every time he withdraws $700, he gains interest on what's left in his bank account. So the interest is covering the extra amount here. And we're going to figure out what that extra amount is. Since it was 5,488.28, this is how much interest he's going to earn. We're going to subtract these two numbers. We subtract 5,600 from 5,488.28. And in the 8 months, with that money in the bank, Victor had earned $111.75, is it? No, that can't be right. Oh, did I? Sorry. Let's try that again. Sorry, I put the wrong number in the calculator. It should be 7.2. So according to this, what we just calculated, this is the amount of interest that he earned keeping that $5,488 in the bank for 8 months. So because he kept that money in the bank, he actually ended up getting the value of $5,600 from only $5,488. His interest covered that extra amount here. Okay, example number 2 in your textbook. Asdef plans to retire at age 60. She would like to have enough money saved in her retirement account so she can withdraw $7,500 every 3 months for 25 years, starting 3 months after she retires. How much must Asdef deposit at retirement at 9% per year, compounded quarterly for the annuity? So again, a lot of information has been given to us. We need to figure out, in terms of our equation, what all of our variables are. So we have our present value formula. First thing we do know, luckily, is the regular payments. It says that she wants to withdraw $7,500 every 3 months. Okay, so there is our R. It says that the interest rate, which is our lowercase r, is 9% per year. Which has a decimal of 0.09. Okay. It says it's also compounded quarterly. So quarterly for our C, quarterly means our C is going to be the number 4. In fact, it's going to be compounded every 3 months in this case. That's the idea to this. It also says that she wants to do this for 25 years. So we know that our years are going to be 25, which is our YR. So because they're doing 25 years, our years are going to be the number 25. Our compound period is 4. And what we've just discovered is we have pretty much all the variables we need. Our uppercase R is 7,500. We can calculate our I with the interest rate, which is our R, divided by the compound period, which is our C. And our N in this equation can be calculated by years times compound period, which is 25 times 4. So we're going to need all those little formulas we also have on the side here. This is going to calculate our interest rate earned per compound period. And N is going to calculate the number of compound periods there's going to be. Okay? So we need to calculate these numbers. We have R, which is important for our formula, so we can highlight that one. We know that's going to go in for our R. We still need to figure out our I. So our I, we'll use a different color here. Our I in this equation, no, 48. Our I is equal to the interest rate, which is 0.09, divided by our compound periods, which is 4. So, in order to figure this out, we need to divide 0.09 divided by 4. Our I is going to be equal to 0.09 divided by the number 4. 0.0225. .0225. Our number of compound periods, which is our N, we'll calculate in color black. Our N is equal to our years, which is 25, multiplied by our compounds periods, which is 4. So our n is equal to 100. So these are the three major variables we need in order to calculate our present value. Okay? We have our I, R, and N, which will help us calculate the present value formula. Okay. So, to calculate this, our PV is equal to the regular payments of $7,500 multiplied by 1, subtract 1, plus our I is 0.0225 to the power of, n is 100, so it's to the negative 100 as a power. All divided by 0.0225. Okay, so we deal with our brackets first, which is our 1 plus our 0.0225. So our present value will be equal to 7,500 multiplied by 1, subtract 1 plus 0.0225 to the power of negative 100, all divided by 0.0225. Then we deal with our exponent. 1 subtract, now we put this in the exponent, 1.0225 to the power of negative 100, which gives you, I'm going to calculate here because I can't see that, to the power of negative 100, 0.1 10806 divided by that same interest rate, which is 0.0225. Our present value is 7,500. We take 1 and we subtract that number.